Hello guys, welcome to Thrill with Physics YouTube channel. In this video, we are going to learn about problems based on Newton's law. So let's start with problem 1. So let's carefully observe the figure first. In the figure, we can see there are two blocks. One is bigger and one is smaller. Both are kept on a smooth surface. And the force M is being applied on the surface of the bigger block. Now the question comes, at what time the two blocks will separate? To find it, we need to analyze the equation of motion carefully. In this case, since the force is being applied on the bigger block of mass m, so this will accelerate. But the smaller block will stay in rest. So now we can find the acceleration of the bigger block, which will be force applied, which is F over the mass m. Now we can write, using this, we can write the equation of motion, which is S is equal to ut plus half at squared. Now in this equation, S is the displacement which will happen with the bigger block. From the figure, the distance covered by the block is L, so the displacement will be L. Now the initial velocity of the bigger block is 0, so this term will become 0. And we can use the expression of acceleration from the first equation and write it as half t square over m. Now our aim is to find the time, so we can reshuffle the terms in equation and write it as 2ml over force. This gives us that our t is equal to plus minus under root 2ml over force. Since time cannot be negative, so we can ignore the negative sign and the final time will be 2ml over force. I hope you understand the concept. Now, our next problem is related to spring constant and a block which is attached to a spring. The question asks you to find the equation of motion of the displaced block. Now if we see the figure carefully, on one side there is elongation and on the other side there is compression. So because of elongation, the force will be kx in this direction, and due to compression, the force will be kx in the same direction. So now the total force will be negative kx, assuming that our frame of reference is this. So now the total force becomes negative 2kx. We know that the force can be written as mass into acceleration, which is nothing but mass into second derivative of our displacement. So we know the force is equals to negative 2kx, which is equal to mr double derivative. Now this x and this r is the same displacement, so we can write it as negative 2k x is equal to mx, and we can rewrite this equation as mx double derivative plus 2kx equal to 0, or x double derivative plus 2kx over m is equal to 0. And this equation is the required equation of motion of the displaced block. I hope you understood the concept and it was helpful for you.